So for systems of inequalities, first of all, for systems of equations, how many solutions are there? Typically one, right? What are the other two options?
No solution.
No solution or infinitely many, right? Systems of inequalities, how many solutions are there going to be?
Well, it's
Either infinitely or none, right? Okay? So the first type of problem that you could see is a problem that looks like this. It gives you a point and it gives you a system. And it says, is the given point a solution to this system? How could we figure that out? Plug them in, right? So we have to make sure we get the right variable in the right place, right? Look, we accidentally did it wrong over here. Okay? But we get the right variable in the right place. Negative 3 is less than or equal to 2 times 4 plus 8. Now, this is the work I expect to see on your homework and on reviews and on tests, yes? This is the work I expect to see, okay? You could write more if you want, but this is what's required. Does everybody understand that? So what's 2 times 4? 8 plus 8?
16.
Is negative 3 less than or equal to 16?
Yes.
Yes, so we could either write a check or yes, okay? Now, second inequality, same thing. I'm putting in x and I'm putting in y, right? So 2 times 4 minus 4 times negative 3 is less than or equal to 5. What is 2 times 4?
8.
What about negative 4 and negative 3?
12.
12. What's 8 and 12?
8, 20.
20. Is 20 less than or equal to 5? So go back to the original question. Is the given point a solution to this system of inequalities? Well, one of them's yes and one of them's no. So what do I write for my answer? Because if any of them are no, then they're all no, right? For it to be yes, for this answer to be yes, all of these have to be yes, right? All of them have to be. In this case, it's 2, right? There's only 2 systems in this system of inequalities. Excuse me, there's only 2 inequalities in this system. But if any of them say no, then the answer is no. Got it? So that's the first kind of problem that you're going to deal with. How do you feel about that?
Good.
Okay? This is the second kind of problem that you could see. So we've got a graph and we've got a system. Would you go ahead and write down the system, please? Yes, sir.
So this week for tests, are we doing it the same way like paper?
So how do we go about graphing this first one? How do we graph that? When there's only one variable, how do we graph it? What's it telling us? Yeah, it's telling us which axis it crosses and where. Which axis is this crossing? The y-axis at 1. So what kind of a line is it? It's a horizontal line, isn't it? Okay. Now, I'm skipping a conversation right here that we're going to come back to in just a minute. Okay, so remember that part. I'm skipping a conversation right here. Everybody understand? Now, where is y greater than 1? Is y greater than 1 above the line or below the line? Above the line, right? Now, if you read the directions in your textbook, what it wants you to do is shade right now, okay? If we start shading willy-nilly right now, it's going to get really confusing. So I don't like to do that. I like to tell myself where I would shade when it's time to shade. Does that make sense? It's going to keep things a lot clearer, in my opinion. Everybody okay with that? So this first graph, I graphed in blue, just so you know. I'm going to graph each of these in different colors so we can differentiate them pretty easily. Okay? If you want to do that, that's fine. If you don't want to do that, that's also fine. Okay? So what about this second line then? What kind of a line is this? It is vertical because it's telling us it crosses the x-axis at 6. 1, 2, 3, 4, 5, 6. If it's crossing the x-axis at 6, it's a vertical line. This is also part of the conversation we're skipping for a second. Now, which side of the line is less than 6?
The one underneath.
So, because this is a vertical line, we don't really have above and below anymore, right? We have left and right, okay? Which side of the line is less than 6? Left. So my question to you then is, do I need to put any arrows down here? Why? Exactly. I already know it's above the blue line. I know it's not down here. My solution is not down here, so I don't need any arrows in there, down there. Does that make sense? Okay? Okay, last equation, last inequality, excuse me. I'm going to graph with orange. Now, the last time we graphed lines, some of you said that you didn't ever do them by hand. You only did them in the calculator. And as respectfully as I can possibly say this, liar, liar, pants on fire. Because I know you did this by hand. I know a lot of you do it in the calculator now, but I need you to know how to do it by hand because all the points are required to be on your graph. Does that make sense? So let's remember, the first thing we do is plot our y-intercept. What is our y-intercept in this problem? So on the y-axis, I go down 5 and I put a point. What's our second step?
The x-axis. Slope.
The slope. What is my slope in this problem? Right, it has to be a fraction, so it's 2 over 1. So from this point, what do? Rise 2, run 1. Rise 2, run 1. Now, how many points do I want to make? Yeah, as many as I can. I want to make all of them that I can. Why do I want to do that?
So you can see your line.
Yeah, it's very easy to see the line if I make all the possible points, right? Now, you remember that conversation I said we're skipping this part of the conversation? Now it's time to actually have the conversation. Okay? Because here's the deal. This one is different than these two. These two, this one was greater than or equal. This one's less than or equal. This one is just less than. When I'm just drawing a line that is just less than, how do I have to draw it? That's exactly right. I have to draw it as a dotted line. Okay? So, the other two, do you see why we didn't have to worry about those? Because that's how we normally draw lines, right? If it's or equal to, it is what kind of a line? It's a solid line, right? A solid line. But if it's just less than or just greater than, what kind of a line is it? It's a dotted line. Does everybody understand that? Now, because it's less than, do I shade above the line or do I shade below the line? Below. Does everybody understand that this is below? Right? If I tilted this line this way a little bit, wouldn't it be easier to see that this is below? Okay? So below the line is right here. So now how easy is it to see your solution? Isn't it just right here? That little triangle area? Please don't get too OCD on me and have to color in every single part of the triangle. Just a little bit. Okay? Now, let's talk a little bit about solutions to this system. First of all, where is the solution to this system? The triangle, right? First of all, will it always be the triangle? No. Sometimes they'll trick you, right? They'll try to trick you anyways, and they'll make this part the solution, or they'll make this part the solution. Don't be tricked. Shade where you know you're supposed to shade, okay? But this is a trick question, so think about it before you answer. How many solutions do I have to this system?
3.
Yes, I have an infinite number of solutions. Now, does it seem logical that I have a finite space, but I still have an infinite number of solutions? That's kind of weird to think about, isn't it? Somebody tell me one possible solution to this system. 1, 2, 3, 4, 5. 1, 2. Would 5, 2 be a solution to this system? Right, make it a black marker real quick. So 1, 2, 3, 4, 5, 1, 2. So do you agree that that is a possible solution to this system? What is another possible solution to this system? 5, 3. Right, that's really close. It's right there. It's still in the shaded area, right?
5.13.
5.1, 3.1. Excellent. Why is that excellent? That's the point I'm trying to make to you, right? There's an infinite number of solutions in here. It's not just exactly where they cross. 5.1, 3.1 is like right here-ish somewhere, right? It's still in the shaded area, isn't it? Now, let me ask you a question about this one. I'm going to put a question mark by it, okay? What about the point 5, 1? 1, 2, 3, 4, 5, 1.
Yes, because it's on the line.
Yes, because it's on a solid line, right? So, yes, this is the solution, right? What about 4, 3? 1, 2, 3, 4, 1, 2, 3.
No, on a dotted line, can't it?
So if it's on a solid line, it is a solution to the system. If it's on a dotted line, it is not a solution to the system. Does that make sense? Any questions about that? All right, what about this system then? Let's do a new system. Let's solve a new system of inequalities. So I'm going to graph the first one in blue. How do I graph that line? I graph the y-intercept first, so I go up 1 and put a point. What is my slope, which is the second thing I do? What's my slope? 2 over 1. Very good. So from this point, I rise 2, run 1. Now, when I have all of my dots graphed, what kind of a line do I draw? How do you know it's a dotted line? Because it is just, yeah, it's not or equal to, right? Now, where would I shade for this line? I would shade above or below? Below because it's less than. Now, where is below? Right here. That's below. Does everybody understand that's below? So down here is below. Okay, so far? How do I graph that one? Plot the -1 first. What's my slope? -3 over 1. So from here I go down 3, right 1. I can also go up 3 if I go left 1. Everybody understand that? When I get all my points plotted, what kind of a line do I draw?
Dotted.
Dotted, very good. Once I draw my dotted line, am I shading above or below?
Below.
It's less than, so I'm shading below. Where is below? To the left of it, right? Right here, that's below. So where do I draw arrows?
To the left.
Just down here though, right? I know it can't be up here, so all I need is arrows down here, right? So where's my solution so far?
Rectangle.
Like right there, right? That's my solution so far, right? Right? Last inequality, how do I graph this? So up 2, and then my slope is negative 3 over 1, so down 3, right 1. Or up 3, left 1.
No solution.
What kind of a line is this? Dotted. They're friends. Once I get my dotted line drawn, where do I shade?
Up.
Because it is greater than, I shade above, right? Now you guys watched me do that whole thing, right?
Yeah.
Did I do anything wrong?
No. There's no solution.
Why do people automatically think that they did something wrong? Because it is what?
No solution.
No solution. Is there one place where everything is shading? No, there's not, right? This is no solution.
I get mad at the no solution ones because I feel like I wasted my time.
I'm sorry about that. Okay, I don't want you to feel like you wasted your time, so can we pretend for just a second? Can we pretend the orange line is not there? When we did this problem a second ago, where is it? Oh, it's right here. When we did this problem a second ago, I said there was 2 ways to figure out the solution, right? And I said, what's the first way? And you said, plug it in. So we plugged it in, right? And I said, we'd talk about the second one in a minute. It's now, right? What's another way I could have solved that system, or I could have figured out if that was a solution or not?
Plug it in.
I could actually draw the system and figure out if the point is in the shaded area, right? So let me ask you this. What if, we're ignoring the orange line for a second, right? What if I said to you, is the point negative 3, negative 20 a solution?
Yes. Wait.
No.
If the orange line is not there, the solution's right here, right? So I'm asking if negative 3, negative 20 is part of the solution.
Well, what is that line?
Yes,
keeps
because
going.
why? It does, exactly. It keeps going, right? We even drew arrows on the end of it. We just don't always think about that. We have to remember that this keeps going. So anything down here, that's still part of the solution, isn't it? Okay, any questions about that? So you remember I told you there was 3 types of possible problems in this section, right? This one was the first one, where it says, here's a point, here's the system. Is it a solution or not? The second type was, here's the solution, graph it. Guess what the last type is? Here's the graph. What's the solution? So I'm going to zoom in a little bit so that you can see it very clearly, because I need you to transfer this to your graph. Now, I will tell you this. 1, 2, 3, that's a 4. That's at 4. That is negative 3. And that right there is negative 5. Okay? So draw this system on your graph.
Yes, draw a
Yeah, you're drawing this. So what I gave you before was the system and asked for the graph. This time I'm giving you the graph and asking for the system.
Hold on.
Do you think we can go backwards like that?
There's got to be a way.
Yeah, there's a pretty easy way in fact. Are you ready?
No.
Not yet? Okay. Thank you to those of you who are telling me you're done as you get done, so I know. Okay? Thank you. Good job. Okay. Okay, are we good to go? Not quite? Okay, that's fine. Ready? All right, so which one of these lines do you want to start with? The horizontal one?
Yeah.
Okay, if we're starting with the horizontal line, remember, horizontal and vertical lines are going to have how many variables? Only one, right? And the way I write the equation is I say which axis it crosses and where. Which axis is this line right here crossing? Where is it crossing? At 4. Now I got to figure out the symbol that goes in between it, right? So first of all, I have to notice, is it shaded above the line or below the line? So it should be less than. But then I also notice that what kind of a line is it? So it also has to be or equal to. Well, there's my first equation. Excuse me, there's my first inequality. Right? What about this? Can we do this one next?
Yeah.
Okay. It's a vertical line, so it's asking which axis is it crossing and where? Where? At -3. Am I shading to the right of it or left of it?
Right.
So that means it is greater than, but it is dotted. So is it or equal to? No, it's just greater than, right? So it's done. Now all we have left is the diagonal line, right? So I'm going to start with y, because that's how we start those. What's the y-intercept? That's the first thing we do when we graph, right? So the y-intercept is -5, so that goes over here. What's my slope? 1 over 1. So can I just put x? Could I put 1x if I wanted to? Yes, absolutely. Now, am I shading above the line or below the line? Above, so this sign is greater than. But I also notice it is dotted, so is it or equal to? No. Okay, done. That's it. You think you can handle that? So if I ask for the system of inequalities is my blue writing. Right? Now, they're scattered all over the page. Is that all right? Yes? It's easy if you put them together so I can find them all, but am I going to count off for this? No, absolutely not. You got the answer, didn't you? Okay? All right, one more. Let's do one more. That's -2. That's -4.
No calculator.
6. That's 9. Okay, does that help? God bless you. Good to go? Not quite? Okay, that's fine.
I'm good.
Thank you. Thank you. Thank you. Thank you. Thank you. Almost there? Okay. Where do you want to start?
Where do we want to start? Let's start
Usually, where do people start on
the
these?
easy ones.
The easy ones, right? The horizontal and vertical ones? So is that okay if we start there?
Yeah.
So what about this one?
So it'd be Y.
Because it's crossing the y-axis at
And you'll put 9.
9. Are we shading above or below?
Above. Wait.
It's less than because we're shading below. See, all the shading that's happening is below. And what kind of a line is it? A dotted, so it's not or equal to, so it's done, right?
Done.
What about this one down here?
That one we'll do Y again. And -4.
Mm-hmm.
It's
Greater than.
It's shading above, so it's greater than.
There's a dotted line, so that's
So it's just greater than, right? It's a dotted line. So now we have these two, right?
Yep.
So the furthest, the highest one, can we start with that one? Okay.
9.
BY.
Intercept is 6. What's my slope? 2. So 2x plus 6. Am I shading above or below? Below, so less than. And
Dotted line.
it's solid, so or equal to, right? And then what about this bottom one right here, the bottom diagonal? Y-intercept is -2. What's my slope on that line? Also 2, so 2x. And am I shading above or below? Above, greater than, or equal to because it is solid. Done. So most of the time people think the hardest part of this is drawing the graph. It's not even hard, it just takes the longest, right?
Yeah.
Okay? Any questions on any of these three things that you have to be able to do?
No.
The first one was what?
Easy.
Is it a solution? Right? Plug it in. Show your work. Yes or no. The second was what? If I give you the system, can you graph it? And the third was, if I give you the graph, can you give me the system? Any questions?